I'm going to demonstrate that here in Hawaii, the Earth is flat. Now, I'm on the island of Kauai. Here's Kauai. Kauai is about 26 miles across. And here is the island of Oahu. Oahu is about 42 miles across. And the distance between Kauai and Oahu from center to center is about 108 miles, according to Google. The highest point on the highest point on Oahu is Mount Ka'ala, 4,026 feet in elevation. Here's another picture of Ka'ala. Now here is a shot that I took early in the morning. You can clearly see Oahu off in the distance. Remember, this is about 100 miles away. This is taken from the Wailua River State Park. There's an overlook here. You can clearly see the landmass. There's another image of it. This is not a mirage, and it's not refraction. Clearly see it. Just did a little pan here to show you where I'm at. This is Wailua River State Park. You can see the roosters off in the background. This is the island of roosters. And there's Oahu. So if we were on a curved Earth, just because of the curve, you would not be able to see this landmass. It's too far away. It would be below the horizon. Now, I've created a little model here. Here's a picture of the Earth from space, or at least allegedly from space. They tell us it is exactly 24,901 miles in circumference. So that's the distance all the way around the spherical Earth. So what I've done is basically created this model. Here's a protractor. A protractor is divided up into 360 degrees. So if I go to the center of this protractor, just want to show you the very center so you can see where these points originate. These lines right here, these are each degrees of arc. Here's the center. This is the 91 degree mark, the 90 degree mark, 89, and 88. Okay, once again, 91, 90, 89, 88. So here's our proportionate Earth. Okay, so here's Kauai. Again, 26 miles across. Here's Oahu, 42 miles across. Here's 1 degree of arc. The way I calculated that is I took 24,901 miles, which is the circumference of the Earth, divided it by 360 degrees, and that gave me 69.17 miles per each degree of arc. So, according to Google, it's 108 miles from the center of Kauai to the center of Oahu. So I created a scale. I'm just going to move the scale over. Okay, so I sized this scale accordingly so that it would be exactly 69.17 miles on the scale from point to point here. And that's how we got our 108 miles here. That's how we got the size of the islands, the height of the islands. Everything is exactly proportionate. Now, to illustrate the line of sight, if you're on Kauai and you're trying to see Oahu, if we're on a spherical Earth, then your line of sight is this red horizontal line. I'll back up a little bit just to give you a wider view of this line. Here's that horizontal line, goes all the way across. Here's our curve. Here's the supposed curve of the Earth. Here's Kauai, here's Oahu. Okay, so you can see the red line. The red line just cuts right through the top of Kauai. So if you're over here and you're trying to look at Oahu, if we're on a curved surface or a spherical Earth, this island would basically be below the horizon. You wouldn't be able to see it. You'd have to get way up in elevation before you'd be able to see that land, this island formation. So technically, you should not be able to see Oahu. Yet I just showed you pictures that you can see Oahu. You can see it. It's clear. Here's a picture of the sun coming up. And this is taken from the same location, the Wailua River State Park. As the sun comes up, you can kind of see how the lighting is slowly changing. Once again, you can see this is not a mirage. It's not refraction. If it was, then the sun would be burning it up as soon as it came up. But you can watch this. You see how the shadowing is changing as the sun gets higher in the sky. So you should not be able to see this landmass if we're on a round Earth. It should be completely obscured by it should be below the horizon. And yet you can see it. Now, it's not that common here on Kauai where you can see Oahu because oftentimes the landmass of Oahu is obscured by clouds or just the air. The air is too thick. You just can't see it. So it's a rare occurrence, and usually you have to get up early in the morning and attempt to view it before the sun comes up. Here's another shot taken even earlier. The camera I'm using keeps going out of focus because of poor lighting conditions, but once again, you can see the island of Oahu. Here's a shot taken at the airport. Now, in a previous video, I had said that the airport was less than 50 feet in elevation, and I was wrong. It's actually 156 feet in elevation. Anyway, you can see Oahu from the airport. Here's another shot of it. And this thing right here, this is a tower, some kind of military telecommunications tower that's on top of Ka'ala. Here's another shot at the airport. Now this shot here, I was able to actually get the sun coming up directly behind Oahu. And I didn't have time to set up my tripod because when I got here it was already happening. So I just had to kind of hold the camera in my hand, so it's a little shaky. But anyway, you can see the sun coming up behind Oahu. Once again, if this was You know, if this was a mirage or refraction, you wouldn't be seeing it like this. And you can actually watch as the sun comes up. It's a beautiful sight. You shouldn't be able to see this if the Earth was round. This wouldn't be here. So anyway, the problem I have with the spherical Earth model is you should not be able to see this landmass. I've just shown you that you can see it. This is probably a better representation of what it all looks like. Here's Kauai, here's Oahu. It's completely flat. That's why you can see Oahu. So anyway, thanks for watching.